The last set for 4.3 is solving exponential equations, and these are fairly easy. These are also on your SAT, so this is good to know on your SAT. So basically, the first one is 53, and we have to solve for x. And since this is called your base, and since your bases aren't the same, I'm going to make my bases the same. Since my bases are the same, I only need to take the exponential part, the power part, and solve for x. So you have 2x plus 1 equals 2. I subtract the 1, I get 2x equals 1. So x equals 1/2. So you're going to write it, your solution set is 1/2. And if you plug it in, plug it back into the original, you get 2 times 2 to the 1/2 plus 1. That should equal 4. So you get 2 to the 1 plus 1. Does that equal 4? Yes, because 2 squared equals 4. So basically that's what you're doing. 55 is 3 to the x cubed equals 9x. So the way I'm going to write this is 3x cubed, so I want to have the same base, so 3 squared to the x. Now, which equals 3 to the x cubed, which equals 3 to the 2x. Now, since my bases are the same, we really don't have to look at those because we're really solving for x. So we get x cubed equals 2 to the x, which I'm going to, anytime you have a cube or square, you want to set this to 0. And we're going to pull out an x, and we get x squared minus 2 equals 0. So basically I have my solution set. This one can be x is 0, and if I set this portion to 0, I get x squared minus 2 equals 0. X squared equals 2. Square root both sides. Don't forget your plus and minus, so x equals plus or minus root 2. So that's your solution set. Okay? 57 is 8 to the x squared minus 2x equals 1/2. This is a good test question, by the way. I'm going to change my base to 2. So I'm going to call this 2 cubed to the x squared minus 2x equals 2 to the negative 1. Now I'm going to go ahead and distribute here, and this is going to be 2 to the 3x squared minus 6x equals 2 to the negative 1. Since my bases are the same now, all I need to do is solve for x. So we have 3x squared minus 6x equals 1. Set this to 0 to find your x's. Alright, and you're going to have to use the quadratic formula on this one, because this is not factorable, and we need all solutions. So basically, I'm going to use the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac over 2a. And we know our a is negative, our a is what? 3. Our b is negative 6, and our c is 1. So we get minus negative 6 plus or minus square root of negative 6 squared minus 4 times 3 times 1 over 2 times 3, which gives you 6 plus or minus square root of 24 over 6. which equals 6 plus or minus 2 root 6 over 6, which equals 3 plus or minus root 6 over 3. And so you can write your solution set as this, or you can write it as 1 if you want to reduce it more. Root 6 over 3 and 1 plus root 6 over 3. Okay? 59. We have 2 to the x times 8 to the negative x equals 4 to the x. So basically I want to change these bases all to 2. So we have 2 to the x times 2 cubed to the negative x equals 2 squared to the x. Simplify this a bit. 2 to the x times 2 to the negative 3x equals 2 to the 2x. Now I'm going to take care of this little bit. This little bit is, remember, your a to the m times a to the n equals a to the m plus n. So this is going to be 2 to the negative 2x equals 2 to the 2x. Now, when I solve for this, I'm going to cancel the 2, so I really get negative 2x equals 2x. So basically, if I subtract 2x from both sides, I get negative 4x equals 0. So x equals 0, so my solution set is 0. Alright, and 61. This is a lot easier than the graphing, right? 61. We have 1/5. This is another good test question. Equals 25. I need to have the same base, so what I'm going to do, you can choose 1/5 as your base. So basically, if you want it to, you could, I'll do it both ways. I'm going to change this to base 5, so this is going to be 5 to the negative 1, 2 minus x equals 5 squared. So this gives you 5 to the negative 2 plus x equals 5 squared. So you're going to get x minus 2 equals 2. So x equals 4. Your solution set is 4. Now what I was saying about changing bases, what if we just change this base to 1/5 to the negative 2? Because that's what it is. Then you would have the same base, right? Once you have the same base, you would just do 2 minus x equals negative 2. And you would also get x equals 4. You're not, restricted to how you change the base. That's just the way most people change it. Okay? 63. Oh. 4 to the x equals 8. This is 63. And basically, we're going to change the base to 2. So that's 2 to the 2x equals 2 cubed. So we have 2 to the 2x equals 3. And it's not even looking at that. So we get x equals 3/2. So the solution set is 3 over 2. 65. This definitely will be on your test. X to the x squared equals x to the 3x times 1 over x squared. So the first thing I'm going to do is rewrite this, and so I can have the same base. Everything's the same base but that. So we're going to write it at 3 to the 3x times e to the negative 2. And this follows the form a to the m times a to the n equals a to the m plus n. So on this side what we get is x squared equals e to the 3x minus 2. And I can cross out my e's. Remember, e is just, 2.718. Don't be scared of e. So we get x squared equals 3x minus 2. Since we have a square, we're going to end up factoring. I'm going to move everything over to the left side. Hopefully we can factor this, so we don't have to use the quad. Yeah, we can factor it. So that's going to be x minus 1 times x minus 2 equals 0. So my solution set is 1, 2. We'll set both of these to 0. Okay, 67. 67 is on your test. If 4 to the x equals 7, then what do they want? What is 4 to the negative 2x? So basically, what I'm going to do is write this here to help me get that. What I'm going to write this as is 4 to the x to the negative 2. Because aren't these equivalent? I just broke this down a little. Now that once I do that, I know that 4 to the x equals 7. So 7 to the negative 2 equals 1 over 49. Okay? So you're just breaking this part down. Let's do one more of those. This was 67. Let's do one more, 69. So they have, if 3 to the negative x equals 2, then what is 3 to the 2x? If then, remember that, 3 to the 2x. So basically I know what 3 to the negative x is. So I'm going to write it this way. Now what can I put here to make that a 2x? Right, negative 2. Because negative 2 times negative x that would be what? 3 to the 2x. So I already know what 3 to the negative x is. That's 2. So 2 to the negative 2 equals 1/4. Alright? I'm going to try 70 for those of y'all that are still watching this. Let's do 70. We have 5 to the negative x equals 3. And so what is 5 to the 3x? So basically I want to write this as 5 to the negative x. That way I can put 3 here. Now what do I put here to make it look like that? Yes, negative 3. Because that would equal, if you multiply by negative 3, that would give 5 to the 3x. So I just put my negative 3 here, and that's going to be 1 over 27. Okay, and that completes 4.3.